This video is on composite functions. Composite functions are when I combine more than one function together. Let's look at an example. Here I have two functions, f of x equals 2x plus 5 and g of x equals 3x minus 1. First I'm being asked to find fg of 2. This can also be described as f after g of 2. And sometimes you might see it written as this, f with a small little circle, g of 2, which just means the same as fg of 2 that I have written up here at the top. In either case, the letter that is closest to the input is the function that is used first. So since g is closest to 2, I use the g of x function first. So I want to find g of 2. So that means I just substitute 2 in as my input into the g of x function. I can use the calculator to evaluate this, and I get 5. I now use the second function, the f function in this case, on the result. I substitute 5 into the f function, and again I evaluate, and I get a final answer here of 15. 15 is my final solution, so I can say that f after g of 2 is 15. Our second example is to find g f of 3, or g after f of 3. This time I use the f of x first, because f is closer to the 3. I substitute this in, and I evaluate it. In this case I get 11. Now I use the g of x function on 11. When I substitute it in, I get 3 times 11 minus 1, which works out as 32. And 32 is my solution. I can say that g after f of 3 is 32. The order in which I apply my functions matters. At this stage, go back and redo part 1 and part 2, except the other way around. Find g after f of 2, and find f after g of 3. Pause the video while you do this, and then play to see if you got your answers correct. The solution for g f of 2 is 26. This is clearly different from 15. So finding f after g of 2 is not the same thing as finding g after f of 2. So the order in which you use your functions matters. Moving on to the second one. F after g of 3 gives us a result of 21. Again, this is different from the 32 that we would get with gf of 3. So again, the order matters, so be careful in a composite function which function you apply first. Example 1 dealt with filling values in and working out a number answer for a composite function. In example 2, we're going to see what happens when we have x's or other letters as our inputs. In this example, f of x is x minus 3 and g of x is x squared plus 1. We want to find f after g of x. Notice we're not given a value, just x. We'll take a similar approach though to before. Again, g is closest to the input, which is x in this case. I'll use g of x first. Since I'm sticking with x as the input, g of x is just going to be written down as x squared plus 1. In this case, I take x squared plus 1 to be the output. Now I want to use the other function, f of x. Remember, to work out f of x, I need to replace x. What am I going to replace it with this time? Well, I'm going to replace it with x squared plus 1. And then I'm going to tidy up my solution. So first I'll drop my brackets, and then I'll tidy it to x squared minus 2. So I can say that f after g of x is x squared minus 2. In part 2, I'm told that h of x equals g after f of x, and I want to find h of x. Now, I've got f of x, and I've got g of x, so what is this h of x? Well, h of x is just the result that I get when I use g after f of x. So really, h of x is just another name for g after f of x. So what I want to do in this question is I want to find g after f of x, and then whatever result I get at the end, I just want to call it h of x. So the f is closest to the x, so I'll use that first. And remember that f of x was given to us at the start of the question, it's just x minus 3. Again, I don't have a value to put in for this, I'm just getting f of x. So I consider x minus 3 to be the output. Now I use the other function, g of x, but I use it on x minus 3. So when I do that, I'm going to replace the x in g of x, which I can see here, with x minus 3 instead. Now watch out, because this x is being squared, so I'll have to put brackets around that x minus 3 when I'm putting it in, and the square will go on the outside of the brackets. I want to do a little bit of tidying up here, so I want to square out x minus 3 and then add 1. Of course, squaring x minus 3 means multiplying x minus 3 by x minus 3. So I'll just multiply this out carefully to get my result. When I multiply my brackets, I get x squared minus 3x plus 9 plus 1. And when I put my like terms together, I get x squared minus 6x plus 10. This is my result at the end of applying f of x and then g of x. So I can say that g after f of x is x squared minus 6x plus 10. But notice that the question said that I wanted to call this h of x, and it said to find h of x. So I should just write the name for this at the end as h of x. So h of x equals x squared minus 6x plus 10. Remember, whenever you're doing composite functions, always use the function which is closest to the original input first.